Good day, students. How are you? Now we will consider the Laplace function, its properties, and the graph. The Laplace function, the Laplace function, Laplace function, its properties, and the graph. The Laplace function is defined by the following formula, and this function is denoted as phi capital bar of x. It is read as phi capital bar, phi bar of x is equal to 1 over square root of 2 pi multiplied by integral from 0 to x of e to minus t squared in half dt. It is the Laplace function. It is Laplace function. Laplace function. Then obtain the connection between Laplace function and error integral. First, express Laplace function by means of error integral, and then express the error integral by means of Laplace function. Here, make the following change. Right change. Let t over square root of 2 is z. Then t is z multiplied by square root of 2, and dt is square root of 2 multiplied by dz. If t is 0, then z also is 0. If t is x, then z equals x over square root of 2. Now rewrite the expression of the Laplace function. Phi bar of x is equal to 1 over square root of 2 pi multiplied by integral from 0 to x, and rewrite this expression t squared in half as t over square root of 2 squared e to t over square root of 2 squared dt. Let it is z. Let the expression in parentheses is z. Then apply this change to this integral. 1 over square root of 2 pi applied from 0 to here x is changed by x over square root of 2, e to minus z squared, and dt is square root of 2 dz. Then we can take square root of 2 out of the integral symbol. Then we will have 1 over square root of 2 pi multiplied by square root of 2 multiplied by integral from 0 to x over square root of 2 of e to minus z squared dz. We can simplify the coefficient of the integral by square root of 2. then we'll have 1 over square root of pi multiplied the integral from 0 to x over square root of 2 e to minus z squared dz. And also you know that the value of the definite integral doesn't depend on the integral variable, and here we can change the integral variable z by new variable t. 1 over square root of pi multiplied by integral from 0 to x over square root of 2 of e to minus t squared dt. Then continue. Then multiply and divide the coefficient by 2 at the same time. Equals 1 second multiplied by 2 over square root of pi multiplied by integral from 0 to x over square root of 2 of e to minus t squared dt. Then remember the formula of error integral. Phi of x is equal to 2 square root of pi multiplied by integral from 0 to x of e to minus t squared dt. It is the formula, the expression of the error integral. Here the upper integral limit is x, but here upper integral limit is x over square root of 2. It means we must substitute x over square root of 2 instead of x in this formula. Therefore it is 1 second multiplied by phi of x over square root of 2. Already we obtained the expressing the Laplace function by means of error integral. That is phi bar of x is equal to 1 second multiplied by phi of x over square root of 2. Then we use this formula, the last formula, for expressing the properties of the Laplace function. Now write properties of Laplace function. The properties of Laplace function. Because already we know the properties of error integral, and we will obtain the properties of Laplace function according to the properties of the error integral. The properties of Laplace function. The Laplace function. First property. The value of Laplace function at 0 is 0 because the value of error integral at 0 is also 0. Phi bar of 0 is equal to 1 second multiplied by phi of 0 over square root of 2. That is 0 divided by square root of 2 is 0. 1 second multiplied by phi at 0. But you know that the phi at 0 is 0. 1 second multiplied by 0 is 0. That is phi bar at 0 is 0. It is our first result. Then find the define this second result. You know that the F integral is odd function, and define the evenness, oddness of the Laplace function. Phi bar of minus x is equal to, here we must substitute minus x instead of x. 1 second multiply phi of minus x over square root of 2. Already we know that the R integral is odd function, and it means we can take the negative sign out of the R integral symbol. We obtain minus 1 second multiplied by phi of x over square root of 2. And it is phi bar of x, it is minus phi bar of x. We obtain the second result. Phi bar of minus x is minus phi bar of x. It means the Laplace function is the odd function. Then write the third property. We will use this formula. The Laplace function is the increasing function, because the R integral is increasing function. For defining the increase-decrease of the given function, we must first find derivative of this function. And you know that if derivative of some function is positive, then it means the function itself is increasing function. But if derivative is negative, negative value, then it means that the function itself is decreasing one. Find the derivative of phi bar of x. Phi bar of x prime is equal to 1 second multiplied by phi of x over square root of 2 prime. Here 1 second is the constant factor which can be taken out of the derivative symbol. We have 1 second multiplied by phi prime of x over square root of 2. And already you know that the derivative of R integral is positive. It means positive. That is, phi bar prime of x is positive. It means our function increasing. Phi bar of x is increasing function. Then investigate the behavior of the Laplace function at infinity. First, define the behavior of Laplace function at plus infinity. For this, find the limit of the Laplace function when x tends to plus infinity. Fourth property, find limit of phi bar of x when x tends to plus infinity. Use this formula, limit when x tends to plus infinity of 1 second multiplied by phi of x over square root of 2. Here 1 second is a constant factor which can be taken out of the limit symbol. 1 second multiplied by limit when x tends to plus infinity of phi of x over square root of 2. If substitute plus infinity instead of x, we will obtain plus infinity divided by square root of 2, and it will be plus infinity. Then we have 1 second multiplied by phi at plus infinity, and you know that the limit of R integral at plus infinity is unit, is 1. 1 second multiplied by 1 is 1 second. It means limit of phi bar of x when x tends to plus infinity is 1 second. 1 second. And finally, investigate the behavior of the Laplace function at minus infinity. Find limit of this function when x tends to minus infinity. Limit phi bar of x when x tends to minus infinity equals limit when x tends to minus infinity 1 second multiplied by phi of x over square root of 2 is equal to here 1 second is a constant factor which can be taken out of the limit symbol. 1 second multiplied by limit when x tends to minus infinity of phi of x over square root of 2. If substitute minus infinity instead of x, then we will obtain minus infinity divided by square root of 2 is will give minus infinity. Therefore, it means we have 1 second multiplied by phi at minus infinity. And you know that at minus infinity the limit of the R integral is minus 1. 1 second multiplied by minus 1 is minus 1 second. That is limit phi bar of x at minus infinity is minus 1 second. Well, we have the following results. According to the first property, at 0 the Laplace function is 0. It means the graph of Laplace function is passing through the origin. Origin in Azeri it is coordinate başlangıcı. According to the second property, the Laplace function is the odd function. It means the graph of Laplace function is the symmetric one with respect to the origin. It means if turn the graph of Laplace function by 180 degrees with respect to origin, then we will obtain again we will obtain the previous graph. According to the third property, the Laplace function is increasing function, increasing one. It means the graph of Laplace function increases. According to the fourth property, the limit of Laplace function at plus infinity is 1 second. It means the line y equals 1 second is the horizontal asymptote. According to the fifth property, the limit of Laplace function at minus infinity is minus 1 second. It means the line y equals minus 1 second is another horizontal asymptote. Then construct the graph of Laplace function. Now construct the graph of the Laplace function. The graph the graph of the Laplace function. Laplace function. Construct this graph. We have two horizontal asymptotes. One of them is y equals 1 second, and another horizontal asymptote is y equals minus 1 second. 1 second. 1 second. Minus 1 second. Y equals phi bar of x. It is the graph of Laplace function. Then continue. Then express the Laplace function by means of error integral. Already you know this formula. That phi bar of x is 1 second multiplied by phi of x over square root of 2. It is the expressing of Laplace function by means of error integral. Now express error integral by means of Laplace function. From here we have phi of x over square root of 2 is equal to 2 multiplied by phi bar of x. Then substitute x. Now we can make the change. Let x over square root of 2 is t. Change. X square root of 2 is t. Then x is square root of 2t. Apply this change to the last formula. Phi of t is 2 multiplied by phi bar of t square root of 2. And if go to the x, that is change t by x, then we finally obtain the following formula. Phi of x is 2 multiplied by phi bar of x multiplied by square root of 2. It is very important formula that it is the formula of expressing the error integral by means of Laplace function. Now express the probability of falling of the continuous random variable with the normal distributive density into the given interval by means of Laplace function, and use this formula. The probability of falling of the the continuous random variable with the normal normal distributive density, into the given interval, by means of the Laplace function, Use this formula. Remember that this probability by means of R integral is defined by the following formula. P that continuous random variable will be situated between alpha and beta, is equal to the 1 second multiplied by phi of beta minus a over sigma square root of 2 minus phi of alpha minus a over sigma square root of 2. This formula is known for you. Now use this formula. First substitute beta minus a over sigma square root of 2 instead of x, and then substitute alpha minus a over sigma square root of 2 instead of x in this formula. P of alpha is less than x, p that alpha is less than x is less than beta is equal to 1 second multiplied by, use this formula, 2 multiplied by phi bar, it is x, beta minus a over sigma square root of 2 multiplied by square root of 2 minus 2 multiplied by phi bar of alpha minus a over sigma square root of 2 multiplied by square root of 2. Then continue. Here this fraction is simplified by square root of 2. Then continue. And here we can take 2 out of the brackets. 1 second multiplied by 2 multiplied by phi bar of beta minus a over sigma minus phi bar of alpha minus a over sigma. Then 1 second, and 2 will be simplified, and then we will have that phi bar of beta minus a over sigma minus phi bar of alpha minus a over sigma. If take a equals 0 and sigma equals 1, we will obtain the following remarkable formula. P that alpha is less than x is less than beta is equal to simply a is 0 and sigma is 1, and then we'll obtain the simplest formula, phi bar of beta minus phi bar of alpha. The next topic is named the median deviation. The median deviation. The median deviation. The median deviation. The median deviation in Azeri is orta yayılma. Orta yayılma. This deviation, median deviation, is denoted by capital letter E, Latin letter E, or Greek letter epsilon capital, or Latin letter E capital. It is such a number. For this, the probability that the continuous random variable with the normal distributive density will fall into the falling into the interval a minus e capital and a plus e capital is 1 second. That is p that a minus e capital is less than x is less than a plus e capital is equal to 1 second. It is the definition of the median median deviation. E is median deviation. Then also you know that the for normal distribution it is symmetric interval. Here A is the symmetry center and E capital is radius of the symmetric interval. And you know that the probability that the continuous random variable with normal distributive density will fall to the symmetric interval doesn't depend on the symmetry center, and here we can take A equals 0. Let if A is 0, if take A equals 0, then we will obtain P capital that minus E is less than X is less than E is 1 second. But then remember the formula of probability of falling the continuous random variable with normal distributive density into a symmetric interval is defined by the following formula. P that X will be situated, continuous random variable will be situated between minus L and L is equal to phi capital of L over sigma square root of 2. Here phi capital is error integral. You know this formula. Here minus L is symmetric interval, and here the symmetry center is 0. If substitute E capital instead of L, we will obtain and this equality, that this probability is equal to 1 second. Then we will have that phi of E capital over sigma square root of 2 is 1 second. Here L is E capital. Then, according to the table of the error integral values, we can define the value of the argument. The value of argument, this argument is denoted by letter, Greek letter rho. Here, from here, E capital over sigma square root of 2 is rho. And rho is equal to approximately 0.47 or 48. Approximately. It is constant value. Then it is rho, and from here we can define the sigma. Sigma equals E capital divided by rho square root of 2. It is a very important, remarkable formula. By means of this formula, the standard deviation is expressed by means of median deviation. Here, sigma is standard deviation. But E capital or epsilon capital is median deviation. And substitute this formula, this sigma, instead of this formula. P that x will be situated between minus L and L is equal to phi of substitute E capital over rho square root of 2 instead of sigma in this formula. L over E capital divided by rho square root of 2 multiplied by square root of 2. Here we can simplify the denominator by square root of 2, and then rho will be transferred into the numerator. Then we will have finally we'll have that P of minus z minus L is less than x is less than L is equal to phi of rho multiplied by L over E capital, which is a remarkable formula. And our lesson ended. Dear students, goodbye, good luck.